When a driver turns the steering wheel, the vehicle changes direction. This seems simple from outside, but inside there is a system of mechanical components that transfer the driver's input to the front wheels. In this animation, we'll explore the complete steering system and see how rotational movement from the steering wheel becomes the turning motion of the wheels. The steering process begins at the steering wheel. When the driver rotates the steering wheel left or right, torque is applied to the steering shaft. The steering shaft is a metal rod that connects the steering wheel to the steering gear. Although the steering wheel may rotate several times from lock to lock, the front wheels only need to turn a relatively small angle. Therefore, a steering mechanism is required to convert and multiply the driver's input. The steering wheel is connected to the steering column. The steering shaft carries rotational motion downward through the vehicle toward the steering gear assembly. Modern steering columns often include universal joints. These joints allow the shaft to change direction and fit around engine and chassis components while still transmitting rotational motion efficiently. Most modern passenger vehicles use a rack and pinion steering system. The pinion gear is attached to the steering shaft. The rack is a straight gear that meshes with the pinion. As the steering wheel turns, the pinion gear rotates. The rack slides left or right. Rotational motion is converted into linear motion. This is the most important motion conversion within the steering system. Connected to each end of the rack are tie rods. The tie rods transfer the rack's side-to-side movement directly to the steering knuckles. When the rack moves, one tie rod pushes. The opposite tie rod pulls. This synchronized movement causes both front wheels to rotate about their steering pivots. When a vehicle turns, the inner wheel follows a tighter path and therefore turns more than the outer wheel. This steering design reduces tire wear and improves cornering efficiency. Without assistance, steering a vehicle would require significant effort, especially at low speeds. Modern vehicles use power steering systems. There are two common types, but I'm only going to explain one, which is the hydraulic power steering. The system consists of a hydraulic pump, a rotary control valve, hydraulic fluid, and a piston integrated into the steering rack. When the engine is running, the hydraulic pump continuously circulates pressurized fluid throughout the steering system. While driving straight, the rotary control valve remains centered, allowing pressure to remain balanced on both sides of the piston. Since the forces are equal, the piston does not assist in moving the rack. However, when the driver begins turning the steering wheel, the rotary valve detects the steering input and redirects high-pressure fluid to one side of the piston while connecting the opposite side to the return line. This creates a pressure difference across the piston. The high-pressure fluid pushes on one side of the piston, generating additional force that helps move the steering rack. As a result, the driver no longer needs to provide all of the force required to turn the wheels. Instead, the hydraulic system supplies most of the effort while the driver simply controls the direction. Once the wheels are angled, tire forces interact with the road surface. As the vehicle moves forward, the tires generate lateral forces. These forces change the vehicle's direction. The car follows a curved path. The greater the steering angle, the tighter the turning radius.